Hello Algebra 2 people. This video is just finishing the notes on square roots and complex numbers. The last one we discussed solving using the square root method, and when you have a negative under the square root you have I in the answer. So this video is just finishing this off. Alright, we're going to be looking at actually performing operations with complex numbers, adding, subtracting, and multiplying expressions that have the number I in them. So to start off with, look at this problem, 8 minus 2i plus 5 minus 2i. Even though I is a number, remember I is the square root of -1, you could treat it just like a variable when you're adding, subtracting, and multiplying. You work these out the same way. All right, you're just going to combine like terms. 8 plus 5 is going to be 13. And negative 2i minus 2i is negative 4i. And that's it. That's the answer. 13 minus 4i. Nothing too complicated there. Now, if it's subtraction, don't just combine like terms. It's not negative 3 minus 1, negative 7i plus I. Remember, you're subtracting these. All right, so you do a negative 3 minus negative 1. You do a negative 7i minus I. So basically, you're distributing that negative. This is really like a plus 1 and a minus I. So negative 3 plus 1 would be negative 2. And then negative 7i minus 1i would be negative 8i. That would be my answer. Okay, so adding and subtracting, pretty easy. You just combine like terms. If it's subtraction, distribute that negative. Multiplying, this is where people start making their mistakes. Okay, because when I'm multiplying, I times 3i, what do you think that is? That is 3i squared. I times I can be I squared. Now, that is correct, but that's not the final answer. Because remember, I squared is this number. It's -1. I is not -1. I is the square root of -1. I squared is -1. So you're never going to leave I squared in your answer. All right, if I have I squared, this is like saying 3 times -1, which is what? It's -3. All right, so when I'm multiplying to number 15, when I'm multiplying each of these out, all right, it's kind of like FOIL. I'm distributing each of these to each of these. So -3 times -3 would be positive 9. -3 times -I, that's going to be a plus 3i. And then 2i times each of these. 2i times -3 would be -6i. And 2i times -I, that's going to be, what is that? -2i squared. All right, so there's my work. Now I can combine some like terms, because first of all, I'm seeing I squared. Remember, I squared is what number? It's -1. So -2 times -1, this whole -2i squared, -2 times -1 is really a plus 2. All right, so now that I've done that, all I've got left to do is combine like terms. I have this 9 plus 2, going to give me 11. And 3i minus 6i going to be minus 3i. And that's going to be my final answer. Okay, so again, multiply, you multiply each by each. Don't leave I squared in your answer. I squared is -1, so -2i squared is really a plus 2. 9 plus 2 going to be 11. 3i minus 6i going to be 3i. It's okay if you have I in your answer, just not I squared. All right, so that's multiplying. One thing I want to point out, a lot of times after I show people this, they're like, okay, I get it, and then when I give them an addition problem, they want to start distributing everything. No, remember, addition and subtraction, you just combine like terms. Multiplication is where you're multiplying each by each. Just want to point that out. Okay, last thing, simplifying these expressions that have I in them. All right, I'm not sure if we're going to have time to get to this in class or not, but when I have something like I to the 14th, I to the 15th, the important thing to remember is I squared is what number? -1. Okay, so basically, every pair of i's is going to give me a -1. So really, this I to the 14th, if I have 14 i's, how many sets of I squared do I have? I have 7 of those, all right? If I'm sorting these into I squares, I have 7 of those, right? Because 7 times 2 is going to give me 14. And remember, I squared is what number? It's -1. So this is like saying -1 to the 7th power. Now, 1 times 1 times 1, 7 times is going to give you 1. Question is, will it give me a negative answer or a positive answer? What do you think? It's going to give me a negative answer. When you have a negative raised to an odd exponent, you're going to get a -1, a negative answer there. All right, so actually we'll come back to B in a minute, but let's look at problem C. I to the 16th. All right, how many pairs of i's is that? Or, excuse me, yeah, I squared pairs of i's. How many? That would be 8 pairs. Right, because 8 times 2 gives you 16. And remember, I squared is what number? It's -1. So this is like -1 to the 8th power. So 1 times 1, again, that's going to give me some kind of 1. Is it going to be a negative or a positive answer? That's going to be a positive 1. Negative to an even exponent is always going to give you a positive answer. All right, now these others, these get a little bit more complicated because when it's I to the 15th, I to the 17th, when it's an odd exponent like that, again, how many pairs of i's can I make? If I have I squared, if I have 15 of them all together, I can make 7 pairs, but I have 1 extra I left over, right? Because 2 times 7, I got 14 i's, but I have another I to make a 15th I. So if I work this part the same way, I squared, remember, is -1. So -1 to the 7th power, we just said, what's -1 to the 7th? It's -1. So I'm getting -1 times I. That answer is going to be -I. And then the last one going to be similar to that. If I have 17 i's, all right, how many pairs of i's can I make? All right, I've got 8 pairs, because 8 times 2 is 16, but I have 1 left over. So now, again, I squared is -1. So -1 to the 8th times I. -1 to the 8th. Is this going to be a -1 or a positive 1? It's going to be a positive 1. Negative to an even exponent is going to be positive. So this is like saying 1 times I, which is just I. So basically, when you're simplifying I to some exponent, your answer is always going to be one of these 4 things. 1, -1, I, or -I. It just comes down to what kind of exponent it is. Like basically, if you have I to some even exponent, it's going to be some version of 1, either 1 or -1. If you have I to some odd exponent, the answer is either going to be I or -I. It just depends on, once you split it up into pairs, how many pairs you have, whether you have an even number of pairs or an odd number of pairs. That'll determine whether it's positive or negative. I hope that was helpful, and we'll talk more about this later. Hotard out.